Sound is all around us. Almost everything around us and in us makes a sound. If we can't hear it, it doesn't mean it's not a sound. Even the blood flowing in our blood vessels makes a sound. If two sounds have same pitch and loudness, they can be differentiated by their quality. Voices of two persons speaking with the same pitch and loudness have different quality of sounds, which allow us to differentiate between their voices. In the same way, two sounds with the same pitch and quality can be differentiated if they have different loudness. The propagation of sound requires a dense soup of particles. The air around you has 10 trillion particles in each cubic meter. It is this huge number of particles that allow you to hear. But this planet of ours is a small bubble which is somehow perfectly tuned for us. Things change drastically when you leave this bubble. You must have come across this quote from the 1979 sci-fi film Alien. In space, no one can hear you scream. Well, that's true, but only up to a point. Sound is a type of mechanical wave that requires a medium to propagate. When we speak, we create disturbance in the air molecule around us. Those molecules then bump into the molecule next to them, creating a chain that travels through the air as a pressure wave. When such a pressure wave strikes the eardrum, it causes the hair cell in the fluid inside the ear to vibrate, creating the electrical signals that are then sent to the brain. Air, water, solid, and any medium which has molecules allow sound to travel through it. But can sound travel in space? To answer this question, you need to know what we mean here by space. The space or outer space is not completely empty. There are some molecules and particles present there. Nebulas, which are enormous clouds of interstellar dust and gas present in the space between the stars and acting as a stellar nursery for new stars, have the potential to carry sound waves. We are just not made to be able to listen to them. And not only in the nebulas, sound can travel in stars themselves. The plasma, which is the fourth state of matter, the matter out of which stars are made, allows sound to propagate through it. Zooming out, this is the galactic scale where the density of particles is 1 atom per cubic meter. On this scale, all the normal matter adds up to less than 5% of the composition. The rest is dark energy and the dark matter which we cannot see. Their existence was discovered by observing their effects on the universe. At first glance, it seems that dark matter might act as a medium for sound, but dark matter does not interact with the normal matter, the matter with which your ears are made. So, should we conclude that on such huge scales, sound just doesn't have enough medium to travel? The theory of relativity was based on the simple idea that gravity is the result of the curvature of space and time caused by the presence of mass. So, if space really does bend, then it should be able to repel, and here emerges the idea of gravitational waves. On September 14, 2015 at exactly 5:51 am, the researchers at LIGO detected the existence of gravitational waves for the first time. Immensely powerful astronomical event like neutron star collision or the collision of two black holes, each with the mass of more than 10 suns, crashed into an extremely small size, send out immense amount of energy in the form of gravitational waves, which travel throughout the universe at the speed of light. If you were near enough such an event, your ear would resonate with the squeezing and stretching of the space. You would literally hear the sound of space, even when there is no medium between you and the source.